Greetings, everyone, and welcome to another episode of The Launch Space. I am here with Aaron today. So we have two Aarons on the show, Aaron Schlesinger and Aaron Wislang. I'm going to introduce those folks in a moment, but before I get started, I did want to mention welcome to those of you who are on the Microsoft Developer YouTube channel. If you want to ask any questions of our guests for the show, please do go over to LearnTV, aka.ms/LearnTV, where we have an interactive chat. You can ask questions and things. And I think we should make it fun. Anytime that I say Aaron without specifying which Aaron it is, I think we should definitely have the folks in the chat call that out, and make sure that I mentioned that. I'll be watching the chat to make sure. So thank you, Aaron and Aaron, for coming. Aaron Schlesinger, do you want to introduce yourself?
Yeah, sure. Yeah, if you don't specify the Aaron, you just get a grab bag. One of us will pick it up.
Random.
Yeah. So yeah, I'm Aaron S. I've been a developer advocate in the Azure group for about 3 years now or so. And I'm focused on the Go programming language and Kubernetes, which is kind of why we're here today. I'm really excited to talk about this project today because, both of us are pretty intimately involved with it. So yeah, really look forward to it.
Yes, I should mention, we're talking about scaling HTTP apps using KEDA-HTTP. And Aaron's going to be covering that, as well as Aaron W. Aaron, do you want to introduce yourself?
Yes, indeed. Yeah, so I'm also a cloud advocate on the open source engineering team on inside of our cloud advocacy org. I also do a lot of work with Go, open source, Linux, containers, Kubernetes, bit of Python. I've built a lot of web apps, a lot of platforms across my career. I did a lot of work in e-commerce and other things like that. So this is a long-term sort of thread of mine. And really love seeing how making distributed systems easier is possible on the Kubernetes platform like this. Look forward to share more about that.
Yeah, thank you. And last but not least, my name is Brian Benz. I'm the host of The Launch Space. It's here every week, Thursdays at 1 p.m. PST. And it's great to have Aaron and Aaron on the show today. And we're going to get started a little bit. We're going to talk a little bit about Kubernetes for those of you who might need a little bit of a catch up on that. And then we're going to talk about the challenges of working with Kubernetes on HTTP. Some of the things that you have to take into consideration for that. And we're going to move into KEDA-HTTP, which is an open source project which addresses a lot of the challenges that you have on when you're working with open source, when you're working with HTTP apps on Kubernetes. So I'll let Aaron and Aaron S and Aaron W are going to tell you a little bit about Kubernetes, and then we'll get into the challenges of HTTP.
Yeah. So Aaron W, the other Aaron, why don't you give it a sort of begin and tell all of us about Kubernetes.
Well, what is a Kubernetes? I started working with Kubernetes a little bit before I joined Microsoft. I guess the 2015, 16-ish time frame, and it was very, very new. And people were just getting into containers, I guess. So a lot of us people were getting into containers, and they're needing to orchestrate our workloads on top of clusters of machines. Well, a lot of us didn't need to orchestrate workloads on top of clusters of machines, but we tried it anyway, and we had a lot of fun along the way. Mm-hmm. And Aaron, you've had a lot of background in this as well. What were you doing at that time?
2015, I discovered Go and Kubernetes, like Go in, I don't know, January or something, Kubernetes in like April. So I was just getting into this as well. I was working at a company that operated its own internal kind of cloud-ish system, sort of like OpenStack, but it wasn't OpenStack. And one thing that struck me was two things actually that struck me. One was they were building a lot of network services, as you probably would expect. And they were building them in Java and C++, which was really time consuming. But the other thing was basically they were building an orchestrator, just kind of like what we see in the open source Kubernetes world now. From scratch, yeah. In C++,
in what language?
probably.
In C++.
Yeah, primarily, yeah. But you saw the concepts. You saw the concept of operators and declarative infrastructure as code. We can get into all that stuff, but to me, seeing Kubernetes open source and start growing very quickly was just really cool validation for these ideas and that internal project. And eventually, Kubernetes swallowed many things, including my career became really closely aligned with Kubernetes shortly thereafter. Kind of like the end of 2015 is when I really started diving in deep.
Yeah, I remember all the pain points. I remember because I've been working with these web apps and things back when I had to sort of rack and, well, not physically rack because I was working with a company called Rackspace where I actually ended up working much later on. But I started out with the racking of the servers and then the virtualization on top of that. And then that made things a bit easier. And then coming back and I saw them do OpenStack and all of this other stuff. And then the orchestrators came out. So there's the Docker Swarm and the Mesos and the Kubernetes, and Kubernetes kind of sort of took the market in that sense, and the community rallied around it. And things, I think, have become piece by piece easier and easier for us. But we all have to find out exactly when do we need container orchestration in these particular things. If I'm just a web developer, do I just stick something on a VM? Do I go look for a PaaS? Or do I really need to, what do I want out of my container orchestration? So that's a key thing.
Yeah. And in this project that we're going to talk about today, we've kind of maybe struggled, or we've had a big challenge on defining, how much abstraction should we provide and how high should it go. So you mentioned, should I use a PaaS? Should I use Kubernetes? Should I use orchestration at all? And that's a really challenging question because it's so case by case. But I think it's helpful to define at a high level what is Kubernetes so you can make that kind of informed decision. And so, of course, there's tons and tons of different ways to say this is Kubernetes, right? There's a lot of different kind of definitions, from the lowest level systems level technology up to the, how should I interact with Kubernetes from an app developer or from a DevOps perspective. But
we'd be here about a couple of hours, maybe the rest of the afternoon, right? If we covered all that.
Yeah. Go get some water, get yourself a sandwich, strap yourself in. But for me, like, I can, in my mind, I distill it down to this to get started trying to define it and make that decision. Kubernetes for me is an operating system for one or more VMs in the cloud, or Raspberry Pis, or bare metal, racked servers, or my laptop, or really any mix of all of those types of computing power. And just like an operating system, it gives me a standard API on top of all that stuff, which gives me the resources. It gives me the concept of a CPU, or computing power, if you will, memory, storage, and networking facilities. And with that API, I tell Kubernetes, I'm going to call this API for computing power. I want X number of CPUs. And then behind the scenes, Kubernetes does all the real heavy lifting to figure out how to give me that amount of computing power, regardless of what's behind the scenes, whether it's a Raspberry Pi or 2,000 Azure virtual machines. So, no matter what it is, it figures out how to give me that and reserve that for me, and then allow me to take advantage of that computing power. And the same goes for the storage and so on and so forth.
And one of the things I like to differentiate between is that a lot of people may not need Kubernetes. If you're doing something on a VM and you just want to use containers today, it's absolutely fine to say, I'm going to Dockerize my application. I'm going to build it into an immutable container image. I'm going to go out there. I'm going to drop it on a VM. But we usually look at Kubernetes when we start to want redundancy, when we don't want to have to deal with networking, the complexity of networking across multiple VMs, when we want scale. So here today, we're going to be talking a lot about scaling out, particularly an HTTP application, and also KEDA, which also scales non-HTTP applications, which is quite important.
Yeah, and you really hit on something there. With containers are different from Kubernetes. They're a building block of Kubernetes, but on their own, they're really powerful technology, and they really encourage great patterns and great practices that you can graduate into Kubernetes if you hit it big and you need the scale, or you need the automation or whatever. But for me, I love containers. I love the abstraction. But if I'm building an app, I start with containers, not with Kubernetes. I start with getting it containerized, getting the Docker files written, getting the container built and pushed to a registry somewhere, ACR or Docker Hub or another cloud, whatever it is. There's many of those registries out there. And once it's pushed, then it's like you said, I get a VM and I run the container on the VM, and that's good for a long time, longer than I want to think, right? You know, I want the fancy technology, but running it there is good for a very long time. And you
And
kind of
even for
know,
multi-service applications, right? You might have a Docker Compose, which brings up your front-end web application. It brings up some caching or some database or something on the back end, or multiple services. Like, you can live for quite a while on a single VM. It's kind of surprising in that.
Yeah.
And of course, we also
Yeah.
have the concept of serverless containers, where in cloud like Azure, we have these Azure container instances where you can just bring up one container, and then that is health checked. You don't care about any of the virtual machine infrastructure under that, and it's kind of like a Kubernetes pod as a service. So that gives us a lot of runway before you have to run into orchestration.
Yeah. Yeah, and there are success stories for long-running applications that are on ACI. They just run, they sit there, the networking is taken care of, like you said, the compute and the redundancy and the resilience can be taken care of there too. And that's all without writing any YAML for Kubernetes. And if you've heard anything about Kubernetes, you've probably heard about the YAML factor, all the stuff you have to write and learn there. And it's just, it works. And it's a container in the cloud with a public IP, and it's routable, and you can stack other cloud services on top of it. It says a lot that you can go that far with containers before you have to go into Kubernetes. But I think, yeah, I mean, you mentioned we're going to talk more about once you get to Kubernetes, what are the concerns, so that you can kind of plan before you reach that point.
And just when I think we'll talk about some of the things that motivate us towards wanting to scale our containers. So we have these containers, we have our applications, our services have become smaller, they become decomposed. We may be building microservices, or we may have sort of front-end services we don't think of as microservices that we're kind of scaling out. What are some of the motivations for scaling out those services that you think of?
Yeah, I think there are, I think we have to kind of talk about two different kinds of scaling, like that action of scaling, because Kubernetes can let you manually do it. You just change the number of replicas basically, and it'll take care of that for you. But then there's the automatic factor as well. And I think the challenge is, after you get to the point where it's not good enough for some reason for your team to continue to change the number manually, that's when you start taking advantage of Kubernetes automatic scaling facilities. But to answer your question, I think from the start, being able to scale up in Kubernetes, meaning give your one process lots of CPUs or more memory and so forth, it's a really great feature of Kubernetes for me, because again, just like an operating system, let's say you want more RAM, you call malloc in the operating system, and that's an incredibly complex operation under the hood, because the operating system has to do garbage collection and clean up and find a continuous block and so on. And Kubernetes does that same thing, except on the distributed systems level. You can do the same thing for CPUs, memory, and so on. But then once you hit this point where your app makes it onto TechCrunch or whatever, and you've got tons of traffic, that's not going to be good enough, because you can't get a machine big enough to handle 5 million requests per second or whatever it is. And then you have to scale out, which some people call horizontal scaling. And that's where this idea of replicas comes in. That's the number that I keep saying you could change. So you've got your app and you want to scale to 5 replicas. Kubernetes is going to find a place to put all 5 of the copies of your app. And by default, it will put those 5 copies onto different virtual machines for resilience and redundancy. So if one of the machines crashes, Kubernetes can rebalance all of the 5 replicas onto the remaining 4. And then if you go later, the next day, let's say, you put a new one back, you spin up a new VM, put it back into the cluster, you come back to 5 replicas, Kubernetes will again see that event and then redistribute. And the steady state at that point will be 1 replica per VM. And this all happens with the exception of you going and putting the new VM back the next day. All of the rest of this stuff happens behind the scenes automatically for you. And there's the power right there.
I think that was probably the wow moment for many of us working with Kubernetes. I remember back when I first saw it, and it was Kelsey Hightower doing demos. I think he was at CoreOS at the time. And it was the get your app up and running and run the kube control scale command and see, wow, we've got the replicas and we're like handling the traffic. Like for people who were in the previous sort of paradigms, that was the kind of the wow moment.
Yeah, and I think that was sort of, the Ruby on Rails build a blog in 5 minutes video. It's on the front page of the Ruby on Rails site. I think you're right. For a lot of people, that was the Ruby on Rails-ish moment. Is to see, before Kubernetes, I've been doing lots of work with Puppet or Chef or SaltStack or whatever else, similar sort of imperative configuration management systems. And to achieve that required scripting and pushing out new configurations to all the different nodes. But now you have this service running all the time in Kubernetes that's watching the state of your cluster. And by watching the state, we mean watching all the things that are happening with networking and storage and compute and so on. It's always watching, it's always on. So the minute that you say, I want to go from 5 replicas to 6, the systems that are running behind the scenes in Kubernetes, they are, A, obviously they notice that change, but B, they kick into gear right away and they figure out a few things. They figure out, where is there an open space for that new replica, that 6th replica? And then they say, all right, I'm going to start the process of getting the new container onto that into that node, into that VM. And then after it's done, I'm going to then see that it's done, and I'm going to go and try to run it with all the right parameters. And it's almost like magic that this happens, that you can watch this happening in real time. And that's the aha for sure.
And what you're talking about there is the work that Kubernetes does itself with its control loops and the different things that run the Kubernetes and the control plane and all of the services and scale out our replica sets and with our pods deployments and all that kind of thing. But now we have people, we're building these systems and platforms on top of Kubernetes, like KEDA, which we'll talk about soon, which actually do many of the same things with the events that we see through the Kubernetes control plane and scale out. In this case, we're using Kubernetes to scale out workloads on Kubernetes. And we do this via things like operators and other sorts of things. Can you tell me more about the platform aspect now that we are sort of building these high value services on top of Kubernetes, extending the API and so forth? Yeah.
So you mentioned this concept there. Control loops. You kind of buried the lead. Not really. I mean, that's such an important part, though, of Kubernetes, and that's what enables the platform aspects on top. I want to remind folks that they can ask questions. But Brian, why don't you come in and just remind folks of that?
Thanks. Yeah, no, this is going great so far. I just want to mention to folks out there who might be watching this on Learn TV and the Microsoft Developer YouTube channel that this is a live broadcast and you can ask questions. Go to aka.ms/learntv, and from there's live chat. You can ask questions, share comments, anything you like, and our guests can work on those as well. So we don't have, we do have one question from Andrew McCallan regarding KEDA. Where or how would you use it? Is there a suggested environment or use case? I think, yeah, he did say that you can answer that at the end. I think we're getting to that, but as long as we cover that during the session. Thank you, Andrew, for that. And if, like I say, if anyone else wants to ask questions, https:/aka.ms/learntv, and we welcome your questions and comments. Thank you.
Absolutely.
And we'd also love to hear what people are building. If you've used Kubernetes before or not used Kubernetes before, if you're building auto-scaling applications already, if you're new to a lot of this, we'd love to hear more about it. So
yes,
ask
comments and questions.
just share what you're up to.
For sure, yeah. We love to hear that stuff. We are developer advocates. We love to hear what people are doing with this technology in the world. So yeah, yes. Please do. So yeah, control loops, and this will get us right into KEDA, actually. Kubernetes kind of popularized and standardized that concept where there's something running in a loop. Imagine a for loop, just always running, never stops unless it crashes and then it restarts. And it's always watching this event stream. And the event stream is all the things that are happening in the cluster. Whether you added a new node or a container crashed or anything, it's just everything that happens. And you've got a loop or multiple loops. And in the default Kubernetes install, there are multiple loops always watching the event stream. And so you've got internal core Kubernetes stuff that's watching, hey, did someone request a new load balancer, or did they request to add another container to the cluster? But then you've also got third-party stuff that's outside of core Kubernetes, like KEDA, that's watching for other things. So KEDA, in particular, is watching for a special type of resource that you submit to the cluster. And that resource is called a scaled object or a scaled job. You can do one or the other. And when
I'm
you
going to
submit
stop you
that
right
resource,
there.
Yeah, please do.
KEDA, what does it mean? I know what it means. You know what it means. What does it? Our audience, it's right there.
Yeah. All right. No, thank you for that. So it stands for Kubernetes Event-Driven Autoscaling, the KEDA. And
it wraps it all together.
I mean, yeah, exactly. I mean, KEDA, KEDA. So obviously the K, the K is the K. It's Kubernetes. But then event-driven autoscaling is the really important feature. You've got the control loops, they're watching events. And once a certain number of events come in, KEDA will automatically go for you and update the number of replicas for your application in the background. So you can hook KEDA up to one or more of like 40 different external systems, cloud systems outside of the cluster. So let's say you want to hook KEDA up to Event Grid. You can say, okay, KEDA, when you see anywhere above, let's say 50 Event Grid messages, I want you to scale this container up. So KEDA will be running in a loop. It will automatically watch Event Grid, and it will watch your, the Kubernetes term is called a deployment, which is a set of one application. So it'll watch Event Grid, it'll watch your deployment. And when Event Grid hits that high watermark, it'll automatically tell Kubernetes, I want you to scale up the number of replicas of my app, of my container. And that happens all behind the scenes, all inside of these control loops. You don't lift a finger unless something blows up, which of course it always might. This is a distributed system, so it might. But 99% of the time, you're just sitting back and watching it happen. It's very, very cool to see.
So KEDA was announced in 2019, and it was born to scale these event-driven systems. So we're thinking of things like queues and events and blob storage and service bus and cron jobs and all sorts of things. They're both open source and in the cloud. Proprietary managed services and all of that sort of thing. So it has all of these different types of events that it'll scale, these scalers, and it's also very extensible, so anybody can come along and they can build their own scaler on top of all of these things, and it's been very good for those kind of workloads. So in terms of scaling out, why would they'd scale out in response to these events? it would scale all the way back down. One of the things I know a lot of people go to KEDA for is its scale to zero capacity. And I found this particularly magic when this first started coming as a wave across the Kubernetes community. People were like, wow, we can scale our workloads to zero. We don't have to have them persistent all the time. We can use our clusters in all sorts of creative ways, or attach serverless compute to them and scale that to zero. And then we're not paying anything. We're not doing any work. So we kind of brought the serverless and the the more persistent worlds together, which was kind of amazing. And we did that with KEDA. We brought our functions framework and ran that on top of KEDA, particularly in the early days. It got containerized and did all of that sort of stuff. Tell me more about the scale to zero and the event-driven side of things.
Yeah. So yeah, KEDA can hook up to tons of different systems. They hook up to system cloud services from the big three, Azure, Amazon, and Google clouds. They can hook up to open source services like Redis or MySQL or Postgres. And they can even hook up to Kubernetes events that are happening internally as well. So you can set up a really evil recursive loop, and you can scale your app based on your app, based on events in your app. You wouldn't do that, but you can hook up to a huge variety of different events from inside of your cluster or externally. And that goes for scaling your app up to handle the additional load of those new events. And then when the events peter out, then it can scale your app back down to account for the fact that you don't need as many replicas of your app to handle all those events. And this is really what we mean by horizontal scaling. It enables you to really rapidly increase the amount of processing you can do at a single time by taking advantage of concurrency. But then, like you said, it can enable you to really save on resources when you don't need that concurrency. And like you said, scale to zero means you scale down to 0 replicas, which means there's nothing, your app is ready to run, it can run, it will probably run in the future, but it's not running at all right now. So you're saving tons of resources that way. You no longer have a VM provision just sitting there waiting to do work. You've got all of your VMs free to do other work. And scale to zero is great in this way because it really turns on this capability to share your cluster, to share that group of VMs in the cloud across tons of different teams and tons of different use cases. So I can have, a web server serving my front end, if it's like an e-commerce page, it's serving my home page, but then I can have another service that's doing, let's say, ads. And when traffic really picks up, I need more servers to handle that ad capacity. And when traffic peters out or is lower, maybe it's the middle of the night, you don't need as much of that capacity. So you scale it down and you enable more of the cluster to be freed up for Kubernetes to utilize for other jobs. Maybe there's a batch process in the middle of the night that you need tons of the cluster to run. Well, all of a sudden you've saved on capacity by opening the cluster up for that batch job.
And at the same time, our cluster, particularly in the cloud, where we're not buying and deploying our own hardware, we may be horizontally scaling our cluster. Busy times during e-commerce season, we might make our cluster bigger so we've got more headroom. So we're scaling our pods horizontally, we're scaling our cluster vertically. So both of these are concepts which are kind of baked into Kubernetes itself. Within Kubernetes as well, of course, we have the horizontal pod autoscaler, which is good for scaling workloads based on CPU and memory and other metrics and that sort of thing. And people automatically scale horizontally, and now we even automatically scale vertically with the cluster autoscaler, which works well in the cloud when you can just get these machines on demand. But the KEDA allows us to scale something all the way down to 0, and then tie into all these different sort of types of events. So that sounds really interesting, particularly for event-driven stuff. So what was on the wish list after this?
Yeah, this is where we get into HTTP. So KEDA has, I don't know the exact number, I think it's above 30 scalers. And we're talking about queues and event systems We're talking about even like cron jobs and CPU scaling and Redis and MySQL. The list goes on and on and on.
External push. I'm just reading down the list now. We've got PubSub. We've got all of the companies, IBM. We've got memory metrics APIs. So that's the native Kubernetes. We've got net streaming, OpenStack, Swift, Postgres, Prometheus. Just tons and tons of different scaling options there.
Yeah, and many. I think most of those are contributed to KEDA by someone who works somewhere that needs that. So someone was using OpenStack Swift. They needed that integrated with KEDA, so they came in and they contributed it. And if you're looking to use KEDA, it's fairly easy to contribute a new scaler to the project, which then enables you to run KEDA and drive your event-based workloads seamlessly. If you install KEDA, you set a little flag, and all of a sudden KEDA is driving your workloads based on the events that are coming out of that new system that you just enabled. So
if the functionality is not there, you can go out there and you just build one. You want to scale based on, my barbecue's got more sausages on it, and you need more things to work on it. Build one of those.
Right, you hook KEDA up to your assembly line, and all of a sudden you need more Legos to be made during the peak time of the day, and KEDA's hooked up now to your assembly line, and you're making more Legos. That's just a top of my head. Random thought, but you can do things like this.
So this raises an important point as well. So this is a community-driven project. It's open source. I can go out there and I can also extend it very easily. Provided I know Go, I can just write the thing to do my thing. So it's we helped initiate this project with other folks in the cloud native community. It's probably worth mentioning that it's a CNCF project. So it became a Cloud Native Computing Foundation sandbox project in March 2020. Tell me a little bit about that.
Yeah. KEDA is in the CNCF. It's the project is maintained and run by folks from Red Hat. There's an independent contractor in the core maintainers, and then there's some folks from Microsoft as well. And it truly is an open community. There's no dictator in KEDA that says this scaler may not go in, or this scaler must go in, or this feature, or anything like that. KEDA is used a lot around industry, across lots of different industries. And those use cases are primarily what drive feature development. It's not folks, coming up with just random ideas and deciding I want to build that for fun. And we see that primarily with the scalers. Oh, sorry.
Yeah. I see the most recent blog actually about why Alibaba Cloud uses KEDA for application auto scaling, and they have a great breakdown there of a lot of the things they're doing. So people are actually taking this project, they're going out there using it with vanilla Kubernetes on whatever infrastructure they choose. It's not tied to us. I mean, we work at Microsoft, but it's not a Microsoft thing in that sense.
Right. Yeah, there's no catch. It's open source software that runs on top of open source software that is Kubernetes, and it really does hook up to tons of different clouds. I've actually run it on many different clouds. I've run it on Azure, and I've had it consuming events from Google PubSub, and that works because it's open platforms and open APIs. And this will get us into the HTTP side of things. You mentioned that provided Go, you can write a scaler. There's even functionality in KEDA to write something you mentioned earlier called an external scaler. And that is a system you can write in any language that you build with a standard API. And KEDA can ping that API and ask, should I scale up or should I scale down? So you don't need to write a scaler and contribute it to core KEDA in their code base. You can write an external one and just hook KEDA up via that standard API. And again, we see, standard APIs let you interoperate with literally anything with the standard KEDA without having to go and modify the core KEDA source code or anything like that. There's a catch with KEDA here.
So KEDA goes out there and it's looking for that event, and it's pulling those events in from my custom thing, and it's saying I'm going to scale based on those events as they come in.
Exactly, and you can also push too. Now there was a new release of KEDA a couple months, 3-4 months ago, that now you're allowed to push events too. You're allowed to say, hey, KEDA, I've got a stream of events that I'm going to push down to you, and then KEDA will react in kind by scaling your app based on that stream. And so there's a big, huge catch inside of KEDA, because if you look down all those scalers, HTTP is not in there. So you cannot automatically scale your e-commerce front end based on, is it a peak time or not? And so we tried to go out and solve that. And it turns out there is a lot more machinery that you need inside of your cluster than just responding to events. And there's a lot of reasons for that. But the primary one is that KEDA scales based on standard APIs, whether they're APIs defined by the cloud services or they're APIs based on a Redis API or a MySQL API, or even like just a syscall to find out how much CPU is being used. But there's no standard API to figure out how many HTTP requests are pending, right?
Yep.
Because you've got tons of different web servers. You can get that information from Apache, but that's different than getting it from Nginx or from a cloud load balancer or something else. Sometimes you can't get that information either.
Now you're having to get it across multiple containers or pods or multiple machines and all the way up, and you don't have one central point, one load balancer, one source of truth to actually get all that data to know how many requests you're getting.
Exactly. Yeah, exactly. And there was a way to do it based on Prometheus. And you could, KEDA had a scaler for Prometheus that would consume the Prometheus metrics at like a ping every second or every millisecond or whatever you wanted to do. And then based on that, it would go and scale. So you could wire it up and you could get something approximately good enough. But with HTTP, this is a critical path request that's coming from a customer that probably doesn't want to wait 1 second for the e-commerce page to load, of course. So we needed to find a way.
Like a chatbot goes out there, and most APIs will only wait like a second or two for you to respond.
Exactly.
If you don't.
Yeah, exactly. So the performance, the latency profile of this is much different, and the throughput profile of this is also much different, because there's a higher penalty to having your events. There's a higher penalty to having a latency of 1 second for an HTTP response versus taking 1 extra second to consume those new event grid events coming through in the background behind the scenes. So it's exactly right. You've got tons of use cases for HTTP, all of which one of the common threads is it's better to be low latency than to be high latency. And it's in fact better to be low latency in most cases, even at the expense of throughput, in many cases at least. So that being said, there's a lot that you have to contend with if you want to write an HTTP app and host it on Kubernetes. And that's before you think about autoscaling. So I was talking about Prometheus, I was talking about, being able to set something up kind of like an ad hoc way to scale HTTP. But all that being said, you still have to learn the concepts inside of Kubernetes around networking to enable getting your HTTP server exposed to the internet. So you've got your compute power, so that's your deployment with pods, and those are the containers running. But then you also have to learn how Kubernetes services work. And then in front of the services, how do you expose those services to the public internet? And once you have that, then you have to start thinking about securing those services with an SSL certificate. And you have to then finally, once you get to that point, you have to think about how are you going to monitor it. And then finally, after all of that, then you have to think about if this is going to be a production high scale system, how am I going to auto scale it? And we mentioned PaaS services. You've got PaaS services around the cloud ecosystem. App services is one of the Azure solutions for it. Those do some sort of auto scaling, but we've lacked some of the auto scaling facilities in Kubernetes for a while for HTTP. We had horizontal pod auto scaling. And there's another project in the ecosystem called Knative that does some of this auto scaling as well. And KEDA comes so close to doing it. And the reason that we built the HTTP add-on is because we wanted to take all of the robust, resilient, battle-tested scaling functionality inside of KEDA, and we wanted to add on top of it all of the infrastructure and facilities to enable an HTTP service to automatically scale based on incoming HTTP requests as the events. So there's a lot to unpack in there. But yeah, maybe we should open it up for some quick questions around the HTTP stuff, and then I can show it sort of in action. What do we think about that?
Doing great so far. Thank you. Yeah, I just want a reminder to everyone, this is a live broadcast. Please go to aka.ms/learntv. If you have any questions, you can post them there and we will answer them. We do have a couple of questions that you've actually already answered from Andrew McCallum. Thank you very much. He was basically just asking where or how should we use KEDA, and if there's a suggested environment or use case. And I think you covered that quite a bit. I don't know if you have anything to add to that at all in terms of suggested environments.
Yeah.
Well, suggested briefly, actually. So KEDA, in the name here, Kubernetes Event-Driven Autoscaler, it needs a Kubernetes cluster. That could be on premises. It could be in our cloud with Azure Kubernetes Service. So you get that full managed capability there. And as soon as you've got a Kubernetes cluster, you can just install KEDA, and then you get all of the functionality that we've spoken about. It's kind of out of the box there.
Yeah, exactly. And or you could actually just have a server under your desk, install Kubernetes out of VM or an actual just a box somewhere, and you could
stack Raspberry Pis.
Yeah, yep. and you can use that. I mean, the thing I'm learning a lot, and I know enough about Kubernetes to just be a little bit dangerous probably, but I do want to just ask you, so have I got this right? So when you're talking about Kubernetes, because one of the main features of Kubernetes is scaling, right? That's one of the things they talk about, scaling, redundancy. And so their auto scaling is based pretty much on hardware, right? Whether it's virtual hardware or physical hardware. If you get over 85% CPU, then you can create a new pod. If you get below 15%, you drop the pod. That's pretty standard stuff from what I understand. Correct me if I'm wrong. But for KEDA, it's more, when you get into more virtualized environments where you're working with a backend data source that doesn't affect your CPU on the box that is running Kubernetes, whether that be virtual or not, or the service that's running Kubernetes. So then you have to figure out some sort of metric for how do I actually scale that service based on the link between my Kubernetes cluster and that service. And to do that, use KEDA. That's where KEDA comes in, right? That's where it was designed to use. It's more sort of software virtualization of the scaling that's already built into Kubernetes, but it just tells Kubernetes to add a new cluster or add a new node to the cluster based on something that happens externally, and that could be
to horizontally scale our pods based on something that happens externally. So we have these event streams from all of these external services, and it makes them available in a sort of a standard format within the cluster and gives you one interface to be able to decide which is the scaled object, which allows you to decide how and to scale. So you're able to change the behavior of how that scaling occurs.
Yes, absolutely. And by the way, for those watching, we are going to these links that we're talking about here, where Kubernetes event-driven auto scaling, the KEDA scalers are actually available on a website, keda.sh. I'll share all that in our show page, and the show page is actually at aka.ms/the-launch-space KEDA HTTP. We can show it. I'll put it in the chat in a moment. There it is. The launch space KEDA HTTP. We'll be sharing all the links there. So if you're watching this broadcast later in the recording, we'll have the links there for you. And no, this is great. And I'll let you get back to, I know, Aaron, you got a demo you're going to show, and then we'll come back for more questions after. So thank you.
Yeah, so we've been talking a bunch. Maybe we should get into it. We should see HTTP scaling in action. So yeah, well,
I always appreciate when I see these things concrete.
Yes, exactly. Like see, the Kubernetes dashboard and all that good stuff. So yeah, let me share my screen here. Cool. So I think everyone can see this. And Aaron,
Maybe you could
speak
zoom
up
in a
if,
tad.
yeah, how's that?
Yeah, just for the folks at home. Yeah. If anybody on the
All
stream
right.
is watching this with like more zoom, you can.
Yeah, shout it out. So I've got two things going on here. Obviously, this is just a plain command line, but this one over here is a Kubernetes dashboard called K9S, not K8S. K8S is kind of an abbreviation for Kubernetes itself. K9S is just a play off of that word, basically. And you might, if you've used Kubernetes, if you've used other systems, of course, they have a web dashboard. This is a convenient little dashboard just inside of the terminal. It shows most of the same kinds of information. So I'll be driving from here, and we'll be seeing the effects of that driving over here. So I'm going to show some pods first. And we've got quite a bit of things going on here already. So we've got some infrastructure. We've got this thing called Ingress Nginx, and this is just a load balancer. It's Nginx running inside of the Kubernetes cluster. Then we've got these three things here. We've got HTTP add-on, and then operator and operator metrics API server. Now this is the KEDA system. These operator and operator metrics API server are just KEDA, the system running. And whoops. And we've got our HTTP add-on here as well. So I mentioned control loops before, and that was on purpose because all of these four things, 1, 2, 3, 4, these are all control loops that are waiting for me to tell Kubernetes to do something. And I'll be telling Kubernetes to start scaling my app in just a second. Now this is my app. So we've got XKCD. This is an app that a colleague of mine, a colleague of Aaron W's, has built. It's a node app that just shows XKCD comics, and that's it. But it's a dynamic web app. It's got 5 replicas, 1, 2, 3, 4, 5. And it's not auto-scaling at this point. It's just got replicas that are ready to scale up or down as necessary. So we're going to look at how do you scale this up or down. So we've got an HTTP scaled object YAML file. So if you've got your app,
from you there.
Yeah, absolutely. So I think this will. How's that?
That's pretty good.
Better?
So. Yeah.
Sweet. Okay. Yeah. So if you've got an app, you've got all the stuff installed that I showed you. This is how you activate the scaling. So you've got this HTTP scaled object thing. You give it a name, and then you say scale target ref. What this is saying is, okay, KEDA, I want you to start scaling my XKCD deployment. And the XKCD deployment is the thing that is driving these 5 replicas here. So I want you to scale this up and down. And then I want you to forward all the HTTP requests that come in to the Kubernetes service, which is essentially a Kubernetes native load balancer. And then down here, I want no lower. I don't want you to go lower than 5 replicas. I don't want you to go above 10. Now I could set this to 0. I could set this to 1 million, and that's all well and good. But if you set this too high, you eventually crash your cluster. You have to add physical capacity to the cluster, add more VMs. So for this, we're going to keep this nice and easy, nothing too high, nothing too low, just to see the effects of the scaling. So we are going to go over here. We're going to kubectl create our file. Kubectl create -f is saying, I want you to take this file, the one we were just looking at. I want you to submit it to the cluster, and I want you to put it into this namespace. That's the same namespace that everything else is in. So
And that's
going
an
back to the
example just
terminal.
direct from our project.
Exactly. That's exactly right.
Just-
So, and you can go to the GitHub page. We're going to link to that. You can see this example, running through. So now you notice we've got two more things. We've got an external scaler and we've got an interceptor. This is internal plumbing as well. You don't have to know how this works in order to see this thing working. So we're going to head back over to the services. We're going to pick up this load balancer IP, and this is the IP that our auto scaling is going to work off of. So if you expose this IP, if you set your DNS to an A record in your DNS to point to this IP, this will auto scale for you. So let's head over to here. We've got our XKCD server. Let's do the fun endpoint. See a comic here. Something about Bill Nye. So you can put any ID in here and it'll show you an XKCD comic. That's always fun. But obviously not really what we're looking for exactly. We are going to send a significant amount of HTTP requests here. We're going to see this thing scale up. So I've got a tool called Hey, and Hey is sort of like a slightly different version of Apache Bench, if you're familiar with Apache Bench. So I'm going to do -N, and I'm going to send 200,000 requests, and I'm going to do -C to send 2,000 requests per second. It's kind of I'm going to batch them up, 2,000 at a time. So we're going to do -N 200,000, -C 2,000, and let me grab the IP address, put it in here, and off we go. So we're going to head back over here, and we should see, there we go. These blue-purple ones, they say container created. This is KEDA magically, behind the scenes, figuring out that, hey, I have more HTTP requests coming in, and they are building up into this queue. They're not being handled fast enough. So now that we've got the queue growing, now we're going to provision more processes behind the scenes to concurrently handle all of the new load. Just like with a queue consumer, just like with something that's consuming event grid events or anything else like that, exactly the same thing is happening here, okay? And you'll see this continue to go up and up and up and up and up and up and up until either this finishes or, sorry?
Until your cluster crashes?
Exactly. And here you go. You can see critical CPU level. I have used up 100% of the available CPU in my little Azure Kubernetes cluster. And if this is the point
we vertically scale.
Exactly. Yes, exactly. I would go in. I can configure Kubernetes to automatically add virtual machines for me, or I can go in and manually do it myself. Of course, in this case, I'm not going to do either thing. I am just going to shut down the load generator. And then over time, KEDA goes through a specific set of steps before it starts scaling back down. But over time, you'll see all of these XKCDs go back down to 5. In fact, it looks like it already started scaling back down. And then at the same time, you'll see all these interceptors go back down as well. Those are some internal plumbing that also needs to scale up and scale down over time. So the cool thing about this is before you could only scale up and down, let's say something like a queue consumer to handle big, huge bursts of traffic into your Azure Event Grid or your Azure Queue or something like that. But now we've got the internal plumbing in the HTTP add-on to allow you to have online services handling user requests from, let's say you're running an HTTP API, or you're running an e-commerce front end or a static site or whatever it is. All of that now can take advantage of the same exact auto scaling. And that's really powerful for us. That's a really big gain that KEDA now has available to us. So yeah, I could go on and on. This is really cool technology. It's really, really useful. I've already been running it in sort of my own personal cluster to do some things. And I'm really excited to see where it goes from here on out. So I think maybe now, Aaron, we should see if we can open up for questions, maybe for the last 5 or so minutes.
We have a couple of questions here. So the first one is, can we use other languages other than Go to build these operators? So I'm expecting this is about Kubernetes generally rather than specific to KEDA.
I think it might be about the autoscaler, but I could be wrong. Person who asked, Lucas, if you want to, you might want to follow up with a specification there. But I'm thinking it's the autoscalers itself, because we talked so much about Go for that. But yeah, either way.
Yeah. So kind of, we mentioned sort of this concept of external scalars and open APIs. So the answer is either if it's a Kubernetes, just a Kubernetes core scalar or operator, or a KEDA scalar. If you build the scalar directly into KEDA's code base, it does have to be Go. But the way that we've built this HTTP one, this is actually an external scalar. And it uses a gRPC API. So it's an open API that supports any of the languages that gRPC supports. So we're talking about Node, Python, PHP, Java, C#. There's more. I know there's more. I'm just Ruby. There's even more than that.
C++.
But if it supports gRPC, C++. So if it supports gRPC, then you can write an external scalar for KEDA, and you can get this kind of performance, this like 100 millisecond or below scaling up and scaling down performance out of it. And of course, open source, open APIs, that's how you get this kind of thing. Absolutely. So I hope that answers the question.
Yeah, I think so. We'll just, Lucas, if you have a follow-on question with that, let us know. It's a live broadcast, open show. So anyone else who has questions, aka.ms/LearnTV, please do join in with your questions. We have one more. JR was asking, what distinction allows us to distinguish between CPU and memory? Yeah. Is there a specific setting, or is there, I'm guessing that was sort of the gist of the question. There's specific settings to track both of those separately, or how would you actually do that?
Yeah, so at the KEDA level, there is a scalar for CPU and there is a scalar for memory. You can combine them. You can scale up, you can have two kind of high watermarks, if that makes sense. And if CPU hits that, you could scale up. And if memory hits a different one, you could scale up. And the HTTP stuff, we haven't gotten there yet. That would be a great issue to submit if you've got a use case for that, JR. Right now, the only thing we scale on is the number of pending HTTP requests, or in other words, the size of the pending queue of HTTP requests. So I hope that helps, JR. I'm not 100% sure if I got everything in your question right there, or if I answered your whole question is what I meant.
And one thing I'll mention is this is, oh, sorry, go ahead, Brian.
No, go ahead, yeah.
I mentioned this is very hackable. This is at quite an early stage of the project as well. So we're really interested in folks' feature requests, use cases, all of that kind of thing. Also contributors. If you have any questions around this after the fact, you're welcome to reach out to us on Twitter. My handle here is AS_W. Aaron is Arschles, ARSCHLES. And we're also on the KEDA channel in the open source Discord, the aka.ms/open source Discord. Which we'll share out in the links as well. We'd love to hear people here in the GitHub issues as well.
Yeah, cool.
Yeah.
We will put those all on the page that's being displayed here, aka.ms/the launch space HTTP. Let me share that in the chat as well on Learn TV. And and
I just want to mention also regarding the contributors, we're very early. We've put a ton of work into documentation and also just making sure we're welcoming environment. So even if you think you're a newbie to Kubernetes or a newbie to Go, if you're interested in this technology, this stuff goes beyond Go. This is a Kubernetes technology. So we're absolutely happy to help you get started, help you get using the tech. If you want to contribute back, to help you get started with Go and contributing back to Go. We think just like KEDA has a bunch of people using it, just like KEDA has a bunch of use cases, we think this will succeed as well if we get a lot of folks using it, getting those use cases.
Perfect. Thanks. That was a great time to wrap up. I'm watching the countdown. And yeah, thank you very much. Aaron Wislang, Aaron Schlesinger. It was wonderful talk. Please do check out our show page. It's in the chat now. We'll hopefully display it in a banner on the screen here. And we'll see you at the next show, Thursdays at 1 p.m. PST. Thank you.
Fantastic.